Hello everyone, welcome back to ArcGIS channel. In this video tutorial, we would like to learn how to conduct suitability analysis in ArcGIS Pro environment. This process helps us to choose the right locations based on a variety of factors that satisfy our criteria and not just guesswork. So let's say you are a GIS expert and decision makers come to you for identifying the best locations to build a new hospital in Anderson County in South Carolina. And let's say they consider 5 different factors for identifying the best location for building this new hospital. The first factor is population density. And obviously the hospitals should serve a large population with higher demands. You don't want to have a hospital in areas with few number of people. So the second one is proximity to major roads. And this is because easy access to hospital is necessary for emergencies, routine visits, and also supply chains. So the next one is slope or topographic slope. And steeper slopes pose challenge for buildings stability and also increase construction costs. So we prefer areas that are flat. So the next one is land cover. We cannot have our hospital on any type of lands. For example, you cannot have your hospital on protected areas or environmentally sensitive areas or forests or wetlands or on water, right? But developed areas are more suitable for building a new hospital. So the next factor is proximity to other hospitals, and placing a hospital too close to an existing hospital is redundant. And the new hospital also shouldn't be too far from other hospitals because it prevents collaborations between hospitals, patients transfers, and emergency backups. These are the weights or importance of each factors that were obtained based on the opinion of experts or previous studies in the same study region. So these weights are hypothetical and very depend on your study area. So as you can see here, population density has the highest importance among these factors. Alright, so we need to obtain the data from appropriate sources, and also we need to convert them, all of the data, from vector format. So vector format means point, line, polygon. So if your data are in vector format, you need to convert all of the data to continuous surface or raster grids. So for the raster grids, the unit is pixel. And all of these rasters must have the same extent and must have the same cell size in order to aggregate them. So in the description, I have provided the link to the source of all of the data so you can easily access the data and customize it for your own study area. So let's begin data collection and preparation process. So first of all, in Lab 9 suitability analysis, extract this zip file and also open up ArcGIS Pro and create a new project. And I'm gonna store everything in Lab 9 folder. GIS Labs, suitability analysis, and OK, and OK. So our study area is Anderson County in South Carolina that I already selected that. Here it is. Anderson County is a small county here. Add that into ArcGIS. So here is our study area. I am going to find the population density at the block group information. So I obtained the population information at the block group level from arcgis.com. And so if you can easily open up this data because it's for the entire United States, or you can download the data. So let me open it up in ArcGIS Pro. So as you can see, a new project with only this data will be open. So and then I am going to prepare it in order to select. So there are so many block groups in across the United States, right? So I am going to only select the block group for the Anderson County. So how can I select that? If I open up the attribute table for this block group information. So I have to look at the FIPS, because if you look at the FIPS for the Anderson County, if you open up the attribute table here, you'll notice that so the FIPS is 45007, right? Now here, I think this one, ST FIPS. So based on this, I can write a query, select by attribute, and then I can say that this is 45007, right? So where this one ST of FIPS, and it's 45007, and then apply and OK. So here is the Anderson County. So I can easily export this data, and I'm gonna save it in my lab 9 folder. I'm gonna save it as Anderson underscore block group BG, and then OK and OK. Alright, so now I don't need this file. I can close this, and so let me just make sure before closing it. So, and then I can open it here Anderson BG, add the data. So here's the information of the population information at the block group. So if you open up the attribute table, so for the block group, the population of each block is almost 600, between 600 to 3,000 to 4,000 people, and the ideal size of the population is 1,500 people. So if you open up the attribute table, and if you look at the population, so ideally the population should be 1,500 people, but it's almost between 600 to 3,000 to 4,000 people. Okay, the field that we need for this analysis, we need population density, which is population per square mile, and here is the pop SQMI is the field that we will use it for our analysis. So remember that this data is a vector data, it's not a raster data. We need to convert this to raster grid based on population square mile. So the second data is proximity to major roads, right? So we already had the road information that we downloaded from Tiger Line, I think in the previous labs, primary and secondary roads of the South Carolina. So the question is, so we have the data for South Carolina, how can I have it for Anderson County? And so first of all, let's load it into ArcGIS. So if you add the data and then go back, I guess it was for proximity lab that we had the roads, primary, secondary roads, and here I think maybe this was for the entire, yeah, it was for the entire South Carolina, but I want to have the road information only for Anderson County. The function that we will use here is clip. So I have to clip this roads with this Anderson County boundaries, right? So click on Analysis tab, and then Tools, and then type clip. So we have two types of clips. The first one is clip for feature data, which is point, line, polygon, and also we will have for raster data that we will see. When you have a raster data, you want to clip it, we will use clip raster. So here is clip feature. So the input feature is your roads, the one that you want to clip is roads, and the clip feature is Anderson County or Anderson BG, doesn't matter, Anderson County, and the output I am going to call this roads. That's it. So we will remember that. So these are the roads for the Anderson County, and then run. So what happens is that if you uncheck this, you can better see the result. So here are the roads that have been clipped with the Anderson County. So I can remove this from the table of content. So the next factor is slope, right? So here, so we need to have the hospital in areas with the lower slope. The flatter, the better, right? So, but in order to get the slope data, we get the slope information from digital elevation model or elevation of our study area, right? So we have to get the data, which is dem, of our study area. So the best website to get the data in the United States at variety of resolution is USGS. So if you go to this website, that I also put the link in the description. So here, first of all, you have to select elevation. So the good thing about this website is that you don't even need to log into this website. So first select elevation products. So 1 arc second is almost 30 meter, okay? So 1 meter, 1/3 means 10 meter, and 1/9 is 30 divided by 9, right? So we have the elevation data at different resolution, which means that each pixel, so for example, 1 meter means that each pixel, which is in the square shape, equals to 1 meter underground, okay? But I am going to use 1 arc second. Why? Because 30 meter is enough for building a new hospital, because if you choose 1 meter, 1/3, so we will have a larger data set, which is not necessary, which is 30 meter is sufficient for our analysis. So you can get the current version of the DM or historical version. So I'm gonna select both for the 1 arc second current and historical. I don't need the others. How you can identify your area of interest, I'm gonna select it based on selectable polygon. And here I'm gonna select the county or equivalent. So when you select the county or equivalent, you have to find the county and then click it on the map, right? So for Anderson County, so as you can see, it's here in South Carolina. This is Anderson County. So you have to select this, and after that, click on Search Products. So when you search and click on Search Products, so you can see, so for example, this one covers Anderson County. This one, all of them. So this one doesn't cover the Anderson County, right? So these are the scene of the satellite images. Some of them, they cover Anderson County, but they are for different dates, right? So doesn't really matter because elevation doesn't change that much. So I am going to select the, so as you can see, all of them are 1 arc second, which means that they are 30 meter spatial resolution. So I am going to so these are very old, 2013, 2017. So I'm gonna probably use 2022. I am going to download it. And now I can easily load it into ArcGIS. So refresh, that's USGS, select and OK. And then, so it wants to calculate some statistics, click yes. And so here is the digital elevation model for Anderson County. Sometimes it doesn't cover the entire county, so you probably have to select both. For example, let's say half of county is here. You have to select, you have to download both satellite images, and then you have to mosaic them. So in ArcGIS, you can mosaic the satellite images, put them together, and have a integrated image. So here we don't have that problem. So I am going to just have this digital elevation model for Anderson County. But first, let's look at the value. So the elevation varies between 49 to 639. And it was, I think, based on meters. So if you want to check it, you have to right click and then properties, go to the elevation tab. And then here we can see vertical unit is meters. So another important information in data is column and row, because it's a matrix of numbers, and there are 3612 columns and 3612 rows in this data. For example, if I want to know what is the, so let me put this on top of the other layers. So I want to know what is the elevation here. So I can click on that. It shows me the elevation is 200 meters above the mean sea level, right? So when I'm closer to the Blue Ridge Mountain here, we have higher elevation, as you can see, right? So I can, to better show the values, I can change the symbology. For example, I want to show that the red color shows higher value. Okay, so as you can see, these areas we have higher values, and these areas we have lower elevation. This is a continuous surface. So this is called raster grid, and I want to clip this raster grid only for Anderson County, right? So what I have to do, I have to go to Analysis tab, Tools, and here type clip, and then clip raster, because this is a raster data set. And my input raster is going to be this USGS. The output extent is going to be Anderson County, right? So I want to just focus on I just want to clip this with Anderson County. And the output raster dataset, I'm going to call this probably DEM, Digital Elevation Model. And then I also want to clip it with the input feature, right? So I'm going to check this out, and if there is no data, do not put any value for it. So, and then run. This is the elevation model, but we also need to get the slope from digital elevation model that we will talk about. As I mentioned, you cannot build your hospitals on any type of land cover, right? So how can I get the land cover information? I get the land cover information from this website, mrlc.gov, or Multi-Resolution Land Characteristic Consortium. So in this website, you have to always look for data and then download. And here I'm gonna say that I need land cover data here. So I just want to filter land cover data. So for the latest data that I have is for 2023. Yours might be different. But what information is in the land cover? So if you click on, I think this one. So land cover is also a raster data. So each pixel shows a specific type of land. Okay, so for example, if the pixel value is 11, it shows open water. If it's 12, it shows perennial ice or snow. And 21, developed areas, low intensity or open space. So these are good for building a new hospital. But you cannot, for example, have your hospitals on open water. You can't have it on wetlands, right? You have to, for example, download the data, and so as you can see, it's a very large data set, 1.3 gigabyte. So what you have to do after you download the data, you just load it into ArcGIS Pro and then clip raster, because this is a raster, clip it with the Anderson County. So I already have done that, so but I just wanted to show you where you can get the land cover data. So if you go back to the suitability analysis, and then I think here, land cover, you can load it into ArcGIS Pro. And when you open up the land cover data, if you open up the attribute table, okay, so here we can see the values are 11. 11 was open water, right? So if you, like for example, click on this, so all of these are open water. You cannot have your hospitals here, right? So we don't have 12, which was perennial ice, right? So we have 21. So these are 21. So these are the number of the pixels that are their values are 21. And 21, according to the legend for the land cover, 21 shows developed or open space. So another thing is I can also check the spatial resolution of the data. So if you right click on land cover properties and then look at so here the cell size is 30 by 30, but is it meter or not? If you look at the linear unit, it's meter, right? And then okay, the unit of measurements is meter, and also it's 30 by 30, which means that each pixel, if you zoom in, so these are pixel, right? So each pixel is 30 meter underground. So the good thing about the land cover data is that it is in the raster format, so you don't need to convert it to the raster format. So for other variables like roads or block group, population density, we need to convert it to the raster, but this one is already in raster format. So let me clear the selected features. So the last variable is existing hospitals, right? So we already had the hospitals in the proximity lab. So we learned that we obtained the data of the hospital for the entire United States from HIFLD, right? Homeland Infrastructure Foundation. So we just need to select by location the hospital and select the location that are in the Anderson County. Another thing is that you can just load the hospitals for the entire US, for the entire South Carolina, it doesn't matter, and then just clip it with Anderson County, clip feature. And it's very simple, so you will get the hospital information. So I already have done that, so to avoid the repetition, so here hospitals and then add, and so let me change the symbol. So here, so these are the location of the hospitals in South Carolina. So now that I have downloaded the data and prepared them for Anderson County, so there are multiple steps that you need to take. So according to this flow chart of the steps that we need for site selection, so we have population density, which is in the vector format. It was in the polygon format. So we need to convert this to raster grid based on pop square miles, right? That field, right? So the type of analysis that we will use is called feature to raster function. Road networks is also in the vector format. It was a line feature. So we need to find proximity to major roads, right? So we have the road information, clip that for the Anderson County. So we will use a function that is called distance accumulation function. So what happens is that it, first of all, it generates a raster grid, and each pixel in the raster grid shows the distance to the nearest road. The slope is already in the raster format, but remember, we have elevation, digital elevation model. We don't have a slope, so we need to convert the DEM to a slope. It is also a raster data. Land cover is already in the raster format, right? Each pixel shows a specific type of land cover, and hospitals are like roads, right? So they are in the vector format. They are point data, so we have to use distance accumulation that creates a raster, and each pixel shows the distance to the nearest hospital. So this way, all of the data layers will be in raster format. Everything is in raster format. But after we convert everything to raster grid, you cannot simply combine them, like for example here, right? You cannot combine the layers. Why? Because they are in different units, right? For example, for the population density, the units is individual per square mile, right? So the distance can be, I think it was based on meters. The slope is based on degrees. Land cover, it has no units, right? So we need to make all of the layers unitless. So another thing is that how we can say that, okay, for example, water is not good for building a new hospital. So how we can say that flat areas are better, right? How we can say that being close to the roads is better? So in order to respond to both of these questions that makes this unitless, and also we can rate or score our criteria, we have to use reclassify function. So what happens in reclassify function? So we reclassify these rasters values based on this scale, based on this common scale. So if, for example, the location, for example, the population density, if we have higher population density, we will reclassify as a 6. The highest population density is better. Lower population density, we reclass it as 5, and so on. So after we reclassify these layers, which makes them unitless, and also we applied, like for example, our criteria in the reclassified layer, we can easily combine them in ArcGIS based on the given weights, right? Based on the weights that we had here. All right, so I think the best way to understand it is to apply it in ArcGIS. So the first thing that I'm going to do is that I have to make sure that all of the output layer is 30 meter by 30 meter, right? Because everything has to be the same cell size, the same extent, and also I have to limit the calculations only to the Anderson County. So in order to do that, you have to go to Analysis tab, and then you have to go to the Environment, and here you have to set some criteria. So first of all, I'm going to say that the output coordinate system, I want to have the coordinate system for everything based on Albers. So projected coordinate system, continental North America, USA contiguous Albers equal area. So I'm going to use the same coordinate system for all of the analysis that I'm going to do. And the extent, I'm going to say that the extent is going to be similar to the land cover data. So I am going to select land cover. And another thing is the cell size is also, I'm going to have it as land cover cell size, which was 30 meter by 30 meter. And also the mask, it shows that all processing will only occur within the mask. Okay, so not outside of the mask. Okay, so I'm gonna say that my mask is land cover and snap raster. This is also very important because, as I mentioned, all of the layers, in order to be combined, so they need to have the same extent. Maybe it doesn't, as I mentioned, it doesn't change the values of the raster, but it adjusts the values, like the cell alignment, a little bit to be like the like this layer. So which layer? I'm gonna again use the land cover for the snap raster, and then okay. So what happens is that, so when we set this, all of the analysis that we will do in raster analysis, the setting is gonna be. Okay, so now let's begin with the population density. I'm gonna turn off all layers and Anderson block group. So if you look at the Anderson block group, open up the attribute, the symbology, and then graduate color based on the population pop SQMI. So as you can see here, so let me maybe a better color. So like this one. So as you can see here, we have higher population density, right? And we know that it's better to have your hospital in areas with the highest population density, right? So in order to convert this from feature to raster, we use feature to raster. So tool. So feature to raster, my input feature is going to be here, Anderson block group, based on pop SQMI. And the outputs, so the output, I'm going to call this pop dense, right? So I'm going to save it here. I'm going to call it pop dense, or I can, yeah, pop dense is okay. Save. The output cell size, as you can see, is land cover. And if you look at the environment, are the ones that we already set. So when you click run, so what happens? It creates a raster. This is the raster. This is not a vector, but look at the values. It's like the same as the Anderson between 31 to 3125 here, right? But this one is now a raster. So what is the problem here? The unit is pop individual per square mile, right? Pop SQMI. So we need to make this unit less. And as I already mentioned, we have to use the function that is called reclassify. So if you type reclass and spatial analysis, so reclassify, so my input raster is going to be pop dense and reclassify field based on value. So I am going to reclassify this to, for example, 6 classes, right? So according to here. So I'm going to reclassify or rate it. So 1 not suitable, 2 very low, 3 low, 4 medium, 5 high, and 6 very high. So obviously the higher population density, we have higher score, right? So I am going to go back to the ArcGIS and again go back to the reclassify here and the spatial analysis. So my input raster is going to be pop dense, and then here, so I'm gonna reclassify to 6 classes. So click on classify. I'm gonna use the natural break and 6 classes, and then okay, right? So the values now are in difference of start from 31 to 189. It's different now. It's based on 6 different classes, but it is obvious that, so when you have a smaller value, it's the lowest, right? So between 31 to 189 is lower population density. So here new means the rate, the new rate that I have. So the lower population density, the worse, right? So it's going to be 1, 2, 3, 4, 5, 6. So it makes sense because here we have higher population density and here we have the higher score. So the output, I'm gonna call this reclass popd, which is okay, and then change missing values to no data, which is okay. So if I have any missing values, just change it to no data and then run. Okay, so again, so here, as you can see, 6 is here. As you remember, here we had in the central part, we had highest population density. So what happened is that here I said that 6 means the highest suitability, right? So in these areas, we have highest suitability for building a new hospital because it has higher population. But these areas, we had lower population density and they are least suitable for building a new hospital. So I can remove the pop dense. I'm just gonna keep the reclasses, right? So the next variable is proximity to major roads, right? So we had the road information. So if I bring it here, so roads here, right? So I want to say that when I'm close to the roads is better, right? And also roads are obviously roads are in the vector format, right? So I have to use distance or distance accumulation. So if I type distance and then select distance accumulation, so first of all, it creates a raster from this. And each pixel in the raster shows the distance or a straight line distance, or it can be different type of distance, to the nearest road, right? So if I click on distance accumulation, my input feature is going to be roads. So the output feature is going to be distance to road, which is okay. And then, so you can also have some barriers, you can have some like cost, direction and of the roads and so on. But everything looks good. I don't want to make it complicated. So as you can also see, look at the environment, everything is also already set because we already set that here, right? And then run. So what happens is that it generates a raster and each pixel shows the distance to the closest road. So as you can see here, so if you change the color to better see the values, so for example, the red color means high value, right? So which means that the distance is high. So as you can see in the green areas, we have the distance is very low. So if you also click on here, the distance is like 600, 200, right? The pixel value for the road. But if you are too far from the roads, like in these areas, we have higher distance. And now I need to, how can I say that being close to road is better, right? So we have to, and also the distance is meter, so I have to reclassify it again. So if I select it from here, reclass, and then the class is spatial analysis. So this is going to be distance road. Again, I'm gonna click on classify. I'm gonna have like, for example, 6 classes and then okay. So here are the values. So when you are close to the road is better, which means that you have to give it higher rate. So here it's gonna be 6, right? Close to the roads. And then enter 5, 4. So when you're too far from the road, it's not good for building a new hospital, right? 3, 2, 1. And if there is no data, no data. And then reclass dist. So this one is not good. So maybe reclass roads. Roads. And then change missing values to no data and then run. All right, so now let's look at the values. So if you are close to the roads, like here, like this color, you get the highest score, right? So when I'm close to the road, which is here, we have the highest score. And then very high, high, medium. So this area is 1 has the lowest score, as you can see. So this color, right, that has the lowest score because they are too far from the roads. All right, so the next one is land cover. And land cover, so let me uncheck the roads and here, so here's the land cover, right? So for the land cover, it's already in raster format and each pixel represents a specific type of land cover. but we need to specify, for example, or rate each type of land cover, right? For example, water or wetland is not suitable. Again, how can I say that? I have to use the reclassify function. So I just directly can use the reclassify function. But before that, let's look at the legend again. So 11, 90, 95, so these are not suitable. You cannot build your hospital in these areas, right? So I'm going to remove this from all calculations. So when I have the value of 11, 90, 95, I replace it with no data. It shows that doesn't matter if they are close to the road, if they are, I don't know, in areas with higher population, you cannot build your hospital in this area. So I'm going to use no data for these values, right? For example, 21, 22, so these are developed areas. So for 21, 22, I'm gonna give the highest score, right? For 23, 24, they are also developed areas, but they have medium to high intensity. So I'm gonna give it, for example, the value of medium, right? So, or for example, grassland areas, they are easier for building a new hospital, so I'm going to give it the value of 5. And I don't know, like for example, for 31, the barren areas, so barren land, or 52 here, shrublands, so I'm going to give it the value of 3, low suitability. And 81 and 82, pasture and cultivated crops, so they are very low suitability for building a new hospital, right? So I need to reclassify based on these values. These values will be replaced with the score. So if you go back to ArcGIS and here type reclass and then spatial analyst, so my input feature is going to be land cover, and here I'm going to use the unique value because it has only very few values, right? Very few unique. So 11, as I mentioned, 11, 90, and 95, we have to use no data. So just copy and paste it because ArcGIS is very sensitive. So 11, 90, and 95, no data. All right, so 21 and 22 are 6. The high, very high suitability. So this one is 4, 23, and 24 was 4. And 31 was low, right? So I'm gonna use 3. 41, 42, 43, all of them are not suitable or very, very, very low suitability. So I'm gonna use 1. 41, 42, 43, and 52 barren land, shrubland, so I'm going to use 3. And 71 has high, I think was grassland, so I'm going to use 5. And 81 and 82 was cropland, so I'm going to use the value of 2. 2. It's good. So reclass land, change missing value to no data, and then run. If you look at the results of the analysis, for the water areas, you shouldn't have any value. So it has to be it has to be excluded for all of the analysis. So if you look at the water, so for example, here we had water, right? So when you reclassify, these areas should be no data. And so let's see. Okay, so here is the result, as you can see. So these areas, as you can see, they have no data because they were water or wetland areas. So we excluded it from the analysis. And so 6, as you can see, like the developed areas, we have highest suitability, and also here are developed areas. So the next variable is a slope, and we obtain a slope from digital elevation model, right? So how can I create a slope from digital elevation model? If you type slope and then slope spatial analyst. My input feature is going to be DEM, digital elevation model. The output is going to be a slope DEM, it's fine. It's going to be based on degree. It also can be based on percent rise. The values of degrees between 0 to 90 degree, which means 90 means a steeper value. Percent rise can go to infinity, but I'm going to use the degree. The method is going to be the planar, and z factor, if the horizontal and verticals are the same, we use 1. So I'm going to use 1 and then run. So it creates a slope. As you can see, the values are from 1 to 90 degrees. So maybe you don't have 90 degree here, but the next thing is that how can I say that flat areas are better, right? So normally a slope above 60 degrees is not recommended, right? So when I use the reclassify function for the slope, so I am going to use like the values that I'm going to select is less than 1 degree, 1 to 2 degree, 2 to 3 degree, until 6 degree, and above 6 degree, I'm going to just remove it from calculation. I don't want to have a building in areas with the above 6 degree slope, right? So above 6, I'm going to put it as no data. So click on classify. I'm going to have 7 classes, so 7, and here you can manually change the value. Okay, so I'm going to say if I change the value, it will change to manual 1, and less than 2, less than 3, between 3 to 4, 4 to 5, 5 to 6, and leave the last one. So anything above 6 degrees is not good. So we don't want to have areas with 48 degrees of a slope, so right? So click OK. So the flat areas is better. So between 0 to 1, I'm gonna give it the score of 6, the highest score, and then 5, and then 4, and then 3, 2, 1. So anything above 6 degree, I'm gonna just use no data. Okay, so I'm gonna copy no data and then put it here. So 6, 5, 4, 3, 2, 1, and reclass slope and change missing values to no data and then run. So for water, I should get no data because it's actually for water, because it's a flat area, I got the value of no data, but since it's already no data for other variable, it will be excluded from analysis. But water is obviously is flat area, that's why it is that got the value of 6, which makes sense. And the final variable that I have is proximity to hospitals, right? So we had the hospital, and so for the hospitals, as I already mentioned at the beginning, it shouldn't be too close to hospitals and it shouldn't be too far from the other hospitals, right? So we had the reclass of, first of all, I have to use the distance to hospital, right? So here, distance accumulation for the hospitals, and distance hosp, it's fine, everything looks good, I don't have any barrier, and then run. Okay, as you can see here, so when you are close to other hospitals, if you remember, so here in these areas, we have lower value, right? So each pixel shows the distance to the hospital, right? So here, for example, it's very close to this hospital, very close to this hospital, right? But when I'm too far, like these areas, you can see the values are too large, right? So now I'm gonna say that I shouldn't be, the new hospital that I'm gonna create, it shouldn't be too far from the hospital, it shouldn't be too close to the other hospital. So I have to, again, reclassify it. So again, if I select reclass, and then reclassify spatial analyst for what? For distance to hospital. And I'm gonna say that I'm gonna classify it to 7 categories based on natural break, and then hit OK. So the new value, because this is too close, so I'm gonna give it the value of 1, and also this is the too far, so I'm gonna also give that the value of 1. So, and then 2, and also here 2, right? And then 4, 1, 2, 4, and also here 4. And also when you are in the middle, it has the largest score. So not too far and not too close, right? So 1, 2, 4, 6, 4, 2, 1. So that's how I scored this this reclassify. So I'm going to call this reclass hosp, so I will remember that. And then reclassify hospitals and then run. Let me show the value. So why it doesn't show the okay, so here it is. So reclass hospitals. So when I'm close to hospitals, it gets the value of 1 to this color, which is not good. When I'm too far also from hospitals, gets the value of 1, this color, right? So medium distance, give value of 2. Like low and medium also we get the value of 4. But when you are not too far, not too close, in the middle, right? So it gets the value of 6, which makes sense. So now that I have rated all of these features, right? All of these factors and all of them are unitless. Now I can combine them, right? Or overlay them based on the given weights that we had, based on the policymaker's weight. So if I want to summarize it, weight is between factors and rate is within the factor. So I rated or reclassified each factors, but the weight is between the factors or for combining the factors. So to overlay this reclassed layer, the function that we use is raster calculator. So if I type raster, there are multiple functions that you can use. Raster calculator is the function that I'm going to use for spatial analysis. I'm going to multiply each factor by the associated weight, add them up, divided by the total weight, and the total weight was 1, right? So if you look at the values here, so I want to multiply each factors by the associated weight divided by the total weight. If you add them up, it's going to be 1, and that's it. So you have to multiply each factors by the associated weight. So again, if you go back here, raster calculator, and so we have reclass. So I can remove the other variables that I don't want. So I want reclass, I don't want this. I have reclassify hospital, slope, reclassify of not slope, DEM, reclassify of land cover, reclassify of roads. I can remove this, reclassify pop density, and everything else I can remove. Maybe just keep the Anderson block group, so I don't need that. So Anderson County, and everything else is just a reclassed. So I can also remove the hospital, doesn't matter. So I will probably need to load it for making the map. So again, go back to tools, raster calculator, and then spatial analyst, right? So the first variable was population density, right? Reclass pop dense. You have to multiply it by the associated factor was 0.27 plus. The next variable was land, reclass land. You have to multiply it by I think 15% plus. The next variable was reclass roads, right? You have to multiply it by I think 19% plus reclass slope multiplied by 17%, and finally reclass hospital multiplied by 22%. So let me make sure. So the output is going to be raster C combined, and yeah, everything looks good. I think the environment is also the same as the other layers, and then run. So your final value should be between 0 to 6, as you can see. So the closer values to 6 shows the highest suitability for building a new hospital. I'm gonna turn off all the layers, right? And also for the Anderson County, maybe I use a no color. And so here is the high suitability. As you can see, for the water areas, they totally have been excluded from the analysis, or the areas that, for example, slope was above 6 degrees and so on, right? So here is the final suitability map based on the criteria that we had. The values that are close to 6 are better for building a new hospital. So for example, again, you can reclassify this, okay? Or you can just classify if you go to the symbology and then maybe use a better color, right? So higher value in these areas. So the blue one, probably, for example, if I say that any values above 5 degrees has the highest suitability, right? So for example, if I classify this and I don't know, just to two classes, right? So it's to two classes, and I'm gonna say that anything less than 5, one class, and anything above 5, another class. So these areas, as you can see, very few areas met the criteria that I had. So let's verify the results. You need to verify the results. So I can, for example, improve the transparency to 50%. So it has to be close to the major roads. Let's see. So these are the major roads. As you can see, it's very close to the major road. In terms of population density, so where is population density? I have to add that into ArcGIS again. Suitability Anderson block group. The population density, if you remember, if I, for example, look at the population density, pop SQMI here. So as you can see, in these areas, we have higher population. That's very interesting, that in these counties, we have also higher population density. That also here was higher population density. And these counties also have higher population density. So it also shows that it's close to the roads, has higher population density. You can also compare it with a slope. So yeah, slope DEM. So in these areas, for example, as you can see, the slope is less than 1 degree. So it's a flat areas. It has the in terms of the population density, almost has very high population density, close to the major roads. Distance to the hospitals, it shouldn't be too close to hospitals, it shouldn't be too far from hospitals. If you look at the land cover, so let's look at the land cover of the state. Suitability land cover here, add. So the land cover in these areas, if you look at the land cover, I'm gonna put it on top of the land cover, okay. So in these areas that we had, like in these areas, look at the land cover type. So if you look at the land cover type, this color. So this is 24, and 24, if you remember, was developed areas. So it satisfies all the. So the next step, the final step, is that we have to have a field trip to the area before building the hospital. So maybe there are other features you didn't consider. Maybe it's a protected area. Maybe it's a military area that you didn't consider. So you have multiple options for building a new hospital in this area. So based on the field trip, you will finalize the area that satisfies all the criteria.